Hey everybody, welcome to Module 6. We're going to be talking about random variables in this module. And like a lot of the things that we've seen earlier in this class, sometimes the terminology is confusing, but hopefully in this intro video you'll see that it's something that we can totally grasp. So what I've done to illustrate what a random variable is I've listed out the 36 possibilities that you could get when you roll two dice. When you roll a blue die and a red die, you could get a 1 in the blue, a 1 in the red, a 1 in the blue, a 2 in the red, all the way up to a 6 in the blue, a 5 in the red, and a 6 in the blue, 6 in the red. So we have 36 total possibilities. Now, a random variable, I'm going to give you the definition here. The definition of a random variable is it is a numerical outcome, a certain numerical outcome of interest in a probability experiment. And when we roll two dice, there might be a number of numerical outcomes that we would be interested in. For instance, we could be interested in the sum of the two dice. And the sum of the two dice would then be what we call our random variable. And that sum, if we considered what that sum could be, you would have sums as low as, you could see if you added 1 and 1, you'd have sums as low as 2. And you can see 1 and 2 would give you 3, 1 and 3 would give you 4. And as you continued looking at adding these, I think the highest sum that you're going to get to is going to be 12, 6 and 6. Now, one of the things that we might also be interested in is we could be interested in maybe not the sum, maybe we're interested in the product of these two values from the red and blue die. And, in that case, the product would be our random variable, our numerical outcome of interest in our experiment. And the products would range from 1 to 2 to 3. And you can see that our products would go all the way up to, looks like we'd have a product of 30, we'd have a product of 36. And so those would be some of the higher products. Or maybe I said, you know what, the numerical outcome of the experiment that I'm interested in is, it's not the sum, it's not the product, it's the number of even numbers. I know that sounds kind of strange, but imagine that we roll two dice, and I say that I'm curious to study the number of even numbers that you get when you roll these two dice. So you could see that, if you had something like a 1 and a 1, you would have 0 even numbers. If you had a 1 and a 2, you would have 1 even number. And since we're only rolling two dice, then the most number of even numbers that you could get when you roll would be 2. And so there would only be a few possibilities for this particular random variable. Now you see I've left another column here because a lot of the times what we do with these random variables is we talk about the probabilities associated with them. And so if I attached probabilities to getting these various numerical outcomes, then I have what's called a probability distribution for a random variable. So that's what this would be down here. Here, I'll denote what that is. So this could be a probability distribution for a random variable. So it's kind of like frequency distribution from before, where we have, the certain values listed out and then probabilities attached to them. It's the exact same here, but we're looking at everything in a theoretical sense. And so, same thing here. I could have a probability distribution for this particular random variable. I could have a probability distribution for this one. Now, one thing that all three of these distributions have in common, all three of these random variables have in common, whether the random variable be the sum, the product, and the number of even numbers, is that you see that the only possible values for this random variable And the only possible values for this random variable, and the same thing here, the only possible values for this random variables, they're all whole numbers. And since you're restricted to whole numbers, like we've seen earlier in the class, we would describe these random variables, all three of them in this case, as being discrete random variables. And so that is actually going to be our point of emphasis in this section. There are continuous random variables, things like, you could look at weights or times or so many different things. But when you're restricted to whole numbers, we consider those discrete random variables. And so that is the focus in Module 6, is we're going to be looking at discrete random variables as well as probability distributions for those discrete random variables. Now, there's a little bit of work here for us to complete these probability distributions, but the sample space, all the possibilities when you roll the two dice, it's all listed out for us. And so we could go through and complete this. I could say, okay, to get a sum of 2, well, I guess there's only one way out of the 36 that would lead to that. So that probability would be 1 out of 36. Or to get a sum of 3, you could get a 1 and a 2, you could get a 2 and a 1, so there's 2 ways out of 36. And so we could go through and list out all of the probabilities here. We're obviously not going to go do that right now, but we could do that. You're also not going to be required to do that as you're going through the work, because a lot of the times the distributions are going to be already made for you, and our goal is going to be to interpret those distributions. And I'll go through that in the next video. But to complete this intro video, I just want you to see though that I really could list out all of these probabilities here. I could say to get a sum of 4, I guess I would have, what would I do to get a sum of 4? I could have a 1 and a 3, I could have a 2 and a 2, I could have a 3 and a 1. So a sum of 4 would be 3 out of 36. A sum of 12, looks like the only way we'd get that is if you had a 6 and 6, so there's 1 out of 36 for that. A product of 1, again, you would need to just get a 1 and a 1. So there's only one way out of 36. And so there's probabilities attached to all of these things. A product of 2, well, I think you could get a product of 2 if you did a 1 and a 2, or if you did a 2 and a 1. Because 1 times 2 or 2 times 1 both give us that product of 2. So that would be a 2 out of 36. A product of 3, I think that's going to be 2 out of 36 also, because you could have a 1 and a 3 once again, and I think the only other one that's going to work there would be a 3 and a 1. So anyways, you can see probabilities attached to all of these different values for each one of our random variables. And like I also mentioned, you're not going to need to construct a lot of these on your own. You are going to be interpreting these random variable tables like you'll see in the next video.